Hi everyone, welcome to the third part of the hexadecimal notation lesson, and in this part we're going to look at converting hex numbers to binary numbers. So one method of converting from a hex to a binary is by first converting it into a decimal number. So if we take the hexadecimal number 1, 1, we're going to put the place values on top, so we have 16 and 1. So we have 16 times 1 gives us 16, and 1 times 1 gives us 1, which adds up to 17 in decimal numbers. So this hexadecimal number converts to 17 in decimal numbers. Now, converting 17 to binary, we simply put the place values 1, 2, 4, 8, 16. So these are the place values for binary, and you can see because binary uses only two symbols, 0 and 1, we are multiplying by 2, like so. Whereas for the hexadecimal numbers, remember, we are multiplying by 16. So converting 17 to binary, we simply see which numbers can go into it. So I know 16 can go into 17 ones. So we put a 1 underneath 16. We have 1 remainder. So 8 cannot go into 1. 4 cannot go into 1. 2 cannot go into 1. 1 can go into the remaining 1. And this number right here is 17 in decimal numbers. So 10001 equals 17. You can also work the other way around. So if you have a binary number like 1 like this, we put the place values on top. So we have 1, 2, 4, 8 and 16 like this. So 16 plus 8 gives us 24, plus 1 at the end gives us 25. So this binary number into decimal numbers equals 25. So I'll just label it here so we don't get confused. So this binary number equals 25 in decimal numbers. So this is binary up here. And then converting this into hexadecimal numbers, we see how many times 16 can go into 25. That would mean it can go once. And so 25 minus 16 gives us 9. And then we put a 9 on this side. So 9 gives us 25 in decimal. But there is an easier way to do this. Instead of converting first to decimal numbers, we can actually convert directly from binary to hexadecimal, or the other way around. Now, if you haven't noticed yet, one symbol in hexadecimal numbers can be represented with 4 binary digits, 4 binary numbers. So for example, if you have the symbol A, this can be represented in binary as 1010, like so. So what you do is, if we take a hexadecimal number like C6, what you can do is just simply split it in half like so, and convert each number into 4 binary numbers, or in 4 binary digits. So 6 in this case would be 0, 1, 1, 0, like this. And C, which represents the number 12, would be converted into 1, 1, 0, 0. It's as simple as that. So you basically convert each hexadecimal unit or number as a single symbol, as a single digit, into 4 binary numbers, and you would get the entire number out like that. And we can test this out. So if we have C6, so we put C underneath 16 and 6 underneath 1. So 16 times 12 is going to give us 160 plus 32 is going to give us 192, like that. Because 10 times 16 is equals to 160, and 2 times 16 gives us 32, so 192, and 6 times 1 gives us 6, so this number is going to be equals to 198. C6 equals 198. Now let's see if 198 would be converted to this binary number over here. So we have 1, 2, 4, 8, 16, 32, 64, 128. So 128 goes into 198 fully, like that. So we put a 1 underneath there, which would mean the remainder would be 70. So 198 minus 128 leaves us with 70. 64 can go into 70, so we can put a 1 right there, and that would leave us with the number 6. So 32 cannot go into 6, 16 cannot go into 6, the same for 8. 4 can go into 6, which leaves us with 2. 2 goes into 2, which leaves us with 0, and then we just put a 0 over here. And as you can see, these two numbers match perfectly. So let's do this with another number. So we have the number FA in hexadecimal numbers. We split it in half. A is equals to 10, so that means we do 8 and 2, like this, gives us the number 10. And for F, which equals to 15, we do 4 ones, like so, and that gives us the binary number from the hexadecimal number. And you can test this out for yourself to see if it works. And you can do it the other way around as well. So for example, if we have a binary number like 1, 0, 1, 0, 0, 1, 0, 1, like this, we can split this in half and we can convert these into hexadecimal numbers. So this binary number equals to 10, so we're going to write A. This binary number over here, 0, 1, 0, 1, equals to 5, so we can write 5 like this. So this binary number equals to that in hexadecimal numbers.